Hello, wonderful people of YouTube. So what we're going to be doing right now is going through some IB questions, specifically from an IB exam on logarithmic functions.
That we were given.
Exactly. And so, firstly, we can see depicted here the three different types of questions you may be asked in a specific one section question for this test. So, firstly, we have ln x squared y. Remember, this is a natural logarithm, and so what that means is it's exactly the same as a normal logarithm, just expressed in a different manner. So here you have natural log with the base being irrelevant, x squared y, okay? That's what you have. And so going back to some basic log rules, we can see that in order to get x squared times y, you have to add the logs. So what you do here is you say ln x squared and then plus ln y, okay? And so also remember that this squared can go like that to the front. So this means it's going to be 2 ln of x plus ln y. Also, by the way, ln, you can say ln if you prefer. So, now we look back to the question. It says ln of x is equal to p. So we have a ln of x right there. So let's just substitute in p. So this is like that, this is like that. I put it in brackets so it's clear. This is p, so 2p plus ln of y is q. So that's just substitution at that point. Right, next question. We see ln of x over the square root of y, okay? Ln of x over the square root of y. So, this may look a bit daunting, and that's fine if it does, but it's not actually very difficult. Because what this means is, we just break it into bite-sized pieces. So, what we can see is it's ln of x minus ln of the square root of y, because this is one of the rules, a different rule in logarithms that states when you subtract, it's division. You add, in this first example, it's addition. So this is subtraction right here. And so you also have to think back to the law of exponents, because what you can think here is that this is the square root. A different way to express square root is raised to the half. So it's y to the half. Okay? And so as we said earlier, when you have something up as an exponent, it can go to the front. So what you do is you say ln of x minus a half ln of y. Okay? And so again, looking back to the question, we see ln of x is equal to p, ln of y is equal to q. So substitute in your values, and you say p minus a half times your value of q. Now, a half times the value of q can also be expressed as q, because it's over 1 essentially. 1 times q is q, 2 times 1 is 2, so it's q over 2. P minus q over 2 is your final answer. And now, finally, we have this. This is an interesting question because it's testing your knowledge or ability to apply one of the other rules, which is called the change of base formula. And so what you can see here is you have your y as your base and your x as inside the brackets. And so what they want you to notice is that you have to say that this is actually the same as ln of x over ln of y, because I shall explain. This is actually just log of x over log of y, but because what you're given with is in ln form, or natural logarithms, you want to keep your natural logarithms the same in your answer here. You don't want to give logs, because then you're going to confuse yourself. Then you're going to be like, great, why is it ln and there's logs? It's too much information. So you simplify it and you say natural logarithms. So what you have here then is, again, simple substitution. P over Q. And that is your final answer.
Okay. So let's take a look at what we have here. We have an exponential equation, i.e. an equation raised to exponents. Seems pretty simple on the surface, but it's not. Don't let it fool you. There are some nuances you have to know to do this question correctly. For starters, let's first look at this question and realize what are the tells. You realize that you have a 4 here and a 2 here. Those are immediately signals. When you see that you have an exponent, right, a multiple 2 on both sides of the equation, your head should start digging. There might be some trick or something that you can do here, especially with exponents and logs. In this case, we can express 4 as 2 squared, right? So you can say that 2 squared to the x plus 2x plus 2 is equal to 3. Let's continue simplifying. When we have exponents, when you have an exponent raised to another exponent rules, you multiply them. So we can express this as being 2 to the 2x plus 2 to the x plus 2. Now we can work with this exponent right here. So when you have exponents that are added to each other, you can split them. For example, in this way, you can say that 2 to the x times 2 squared is equal to 3. This is what you can do all the way out on the side here. So when, for instance, you have 2 to the x plus 4, for example, we'll say even 2x plus 4. You can say it's 2 to the 2x times 2 to the 4th. That's just how the rule works. Anyhow, back to the question. Plus 2 to the 2x. Now, when we have 2 to the 2x, you can split that once again. You can say it's 2 to the x squared, because as I just said, when you have exponents raised to an exponent, you multiply them, right? We can say that these are in any way, you don't need this necessarily, you can have it be 2 to the x, or you can have it be x times 2, right? This is equal, those are the same thing. The order of them does not matter, not even a little bit. So, back to the problem. We can rewrite this then, right, as 2 to the x squared plus 2 to the x times 2 squared is equal to 3. Now, we're going to use substitution here. We're going to say that 2 to the x here is equal to y. Okay? So now we're going to say that y squared plus 4y is equal to 3. Y squared plus 4y minus 3 is equal to 0. But wait, that's not factorable. Of course it's not factorable, so we have to use the quadratic equation, which reads as x equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Sorry, I'm a righty. Everyone see that? Cool. Input the values here, being that this is a, b, and c. Everyone gets this right? So x is equal to negative 4 plus or minus the square root b squared, which is 16, minus 4 times 1, because there's a 1 coefficient here, right? Times 3, all over 2. 2 times 1. So we're going to simplify this. Negative 4 plus or minus. This will be minus 12, square root of 4, right? Over 2. X is equal to negative 4 plus or minus 2 over 2. So then, oh sorry, this is y. I apologize, because we're using y from our variables. Sorry, old habits die hard. Y is equal to either, right, we're going to have negative 1 or 3. So now we're going to re-input our substitution. Right here in this step, we said that this is equal to 2 to the x. So now we're going to re-input this in. We're going to say 2 to the x is equal to negative 1. Well, that's impossible. This is impossible. You cannot have an exponent that gives you a negative number. It doesn't work. So this doesn't work. Or 2 to the x is equal to 3, in which case we're going to use our log rules, and we're going to say that log base 2, wait, a, b, c, a, c. Yeah, log base 2 of 3 is equal to x. Making this our final answer. If you want to pause the video here, these are the steps. Cool.
Okay, ladies and gentlemen, so what we're going to do now is we're going to look at a harder question. This is a 7-point question. So yes, it is daunting, but with a bit of what I said last time, bite-sized pieces, very slowly and methodologically, with all of the rules and laws and everything else you've been given, it should be doable. So, I am here to explain how to do this. So, what you do essentially is, you look at this question and you're like, right, what do we see here? Firstly, you want to isolate the x's, right? And so you think, how do I isolate the x's? Well, first, you get rid of the logs. So how are we going to get rid of the logs? So you rewrite log base 4, 2 minus x. But then on this side, you can't get rid of the logs by having a different log on this side. So you have to make this base somehow the same. And so there's a specific rule to do this. Maybe you have been taught this, maybe you haven't been taught this. But either way, the rule states that you have to say log to the 4 squared, because what's 4 squared? 60. So 4 squared, right? And this 2, because it's as a base, converts to a half in the front. Like we said earlier, when you have, for example, log of x squared, what happens to this squared if you prefer it not to be there? It can go to the front. This is precisely what's happening here, although this is a slightly different thing. Because the 2 is not going to the front as a 2, it's going to the front as a half. So, that's what happens, and then you get 13 minus 4x. So, you get that, right? And so now, going back to the other rule, what can you do? This can go up. Because you want the logs to be the exact same. So this goes up, and so you get log base of 4, 2 minus x, is equal to log base of 4, 13 minus 4x, all of it to the exponent of a half. Okay? Now, what can we do now? As I mentioned earlier, we want to get rid of the logs. So you can cancel these logs out. Now all you have, effectively, is you have this. 13 minus 4x to the half. Okay? That's what you have now. And so you're thinking, this half looks disgusting. I don't want that half there. Half just complicates everything and makes life horrible. So, how do you get rid of it? You square both sides. And remember, anything you have to do to one side, because it's an equal, you have to do to the other side. So we square this, so that's that, and then you square this on this side as well. There. Okay, cool. Please look through my steps if you're confused, but it should be quite self-explanatory. Now, these, you can notice 2 times 1 is 2, 2 times 1 is 2, so this is just 2 over 2, which is 1. Anything to the 1 is the expression itself. So, what you have now is this. 2 minus x. Let's expand this because you can say that this times this whole expression. So, to expand this is a method I do. Don't worry if you get confused, this is just how I expand. This is quite a common way of expanding. This is basically just FOIL, just a more sort of simpler way to view foiling of polynomials. 13 minus 4x, you can drop the brackets because they're irrelevant now, because now we've understood that you have to square both sides. And so what you get now is 4 minus 2x minus 2x plus x squared equals to the value of 13 minus 4x, okay? So now what you do is you say 4 minus 4x plus x squared equals 13 minus 4x. Now, because we're running out of space, let's simplify this. So, notice, minus 4, immediately they cancel. Adios to these terms. Okay, we have x squared plus 4 is equal to 13. Okay? That's what we have now at this point in time. Now, remember you subtracted 13 to get to the other side, so what you have now is x squared minus 9 equals 0. Okay, that's what we have at this point. What do you do now? Well, to solve for x, you add the 9, this is basic algebra, to x squared. X squared equals 9. Now, how do you solve for x? You square root both sides, you get x is equal to plus or minus. Do not forget that, because that is an extremely common mistake to make. So always remember square rooting is plus or minus in front of the square root sign. Then plus or minus the square root of 9, which is in other words, x is equal to positive 3, or x is equal to negative 3. But you are not done, because this is a logarithmic expression. So you need to plug in these values to see which of them doesn't work, or maybe both of them work, but that's unlikely. So what you do is you take, for instance, the 3. Let's take this 3 as you can see here. X equals 3. Let's see if that is actually correct by plugging it into one of these original logarithmic expressions. Now, I'm going to go for this one because I just think that might be funner to do. I also know that it's the one that messes the whole expression up. So that is why we're doing this one. Anyway, so let's plug in x equals 3 into this expression. Log of 4, 2 minus 3. Okay, log 4 minus 1. Now, pause the video if your brain is going ding ding ding, because it should be. You cannot have a negative inside the bracket of a logarithmic function. You simply cannot do that. If you input this into your calculator, it will say error, with good reason, because you cannot do that in a logarithmic function. So, you reject this option, and your final answer, obviously if this was on a test, you would test it in this function as well. You'd also test this value in these functions, just to make sure, because this is a 7-point question and you don't want to lose a point at the end of the question. But I know, pause the video if you'd really like to go through and double check to make sure that this is correct, but I know it's correct. So the final answer on an IB exam, you would express this as rejected decision, or rejected option, doesn't really matter. Okay, and you'd say, therefore, x is equal to 3. That is your final answer.
Okay, ladies and gentlemen, boys and girls, here's how we're going to do this one. So the question reads, solve 3 to the power of x minus 1 is equal to 2 to the power of x plus 3, and express it in terms of x is equal to the natural log of a, and x is equal to the natural log of b. Okay, so let's get started. Let's rewrite this. 3 to the x minus 1 is equal to 2 to the x plus 3. First thing I want to do is make sure I get the x's as constants. So what am I going to do? Well, I'm going to notice that this is a natural log here. Right? Everyone seen that? So I'm going to take the natural log of both sides. ln 3 to the x minus 1 is equal to ln 2 to the x plus 3. Well, when we have logs and exponents, what do we do with them? Put them in front. X minus 1. The reason I express it like this is to show that the natural log of 2 is being distributed to both these terms, right? It's like distribution. You can say it's like going to be each of these. Everyone seen that? Cool. Awesome. So now, as I said, we're going to distribute it. We're going to say the natural x times the natural log of 3 minus ln 3 is equal to x times the natural log of 2 plus 3 times the natural log of 2. Everyone see how I got that? I distribute it. Cool? Great. Let's get the x's on. Let's switch the x's to each this side of the equation and this to this side of the equation. So we're going to say x ln 3 minus x ln 2 is equal to 3 ln 2 plus ln 3. Cool, great, everything's awesome. X, isolate it. So we have an x in both these terms, so we can factor it out. X times quantity ln 3 minus ln 2 is equal to 3 ln 2 plus ln 3. I'm going to transfer this work up here. Okay, everyone get this step? Awesome. So we're going to take x is equal then. We're going to divide this, right? Everyone see that? So that way we cancel this out. Cool? Is equal to 3 ln 2 plus ln 3 over ln 3 minus ln 2. Now, how will we go about from here? It may seem confusing, but it's really not. We want to cancel out the logs, right? So let's continue. ln 2 to the power of 3 plus ln 3 over ln 3 minus ln 2. Does everyone see how I took the 3 and put it as an exponent? Cool. Is equal. Now we're going to distribute it. ln 8 plus ln 3 over ln 3 minus ln 2. When we have addition, right, of two logs with the same base, we can multiply the internal term. And when we have subtraction between the logs of the same base, we can divide. So we can express this then as x is equal to the natural log of 8 times 3 over the natural log 3 over 2. Cool? Right? So now, this is the answer. This literally gives us this form. Right? So we can just finish this off. We can say that x is equal to the natural log of 24 over the natural log of 3 halves. Right? And at this point, you'd circle it. Pause the video here if you want to get a quick idea of how I did this. Once again, I'll just rehash all the steps. We took the natural log of both sides of the equation, right? Because when you do one side of the equation, you have to do the other. We then moved the exponents out in front, because when you have exponents on a log, they can be written as coefficients. We then distributed this coefficient to the log, and then isolated all the x's on one side of the equation. We then factored out the x in this step, getting us this, and we divided by this. Then once we had everything right here with x all on one side of the equation, we then took our coefficients and re-expressed them as exponents, because that's what you can do with logs. If you have a coefficient, they can be expressed on an exponent. Then we realized that we had all logs of the same bases on the numerator and the denominator of fractions. So we combined them, because we saw we had addition and subtraction. Addition we multiply, subtraction we divide, and we got a final answer. That's how you do this question.
Okay, ladies and gentlemen, so we're going to do another question. This is a 6-mark question, meaning that it is complicated. Well, it's not complicated, it just has many aspects to the question. Always bear in mind that whenever there's a question with a lot of points, it doesn't necessarily mean that it's impossible. All it means is there's a lot of steps to the answer. So, what the question states is that log base 3 of x minus 4 is equal to 1 plus log 9 of x. Okay? Now, let's start. So, first of all, you want the same bases, because with the same bases you can take out all the logs, as I mentioned previously. So, this is a base of 3, this is a base of 9, and this is a 1. So, let's just think, 9, how can you re-express that into 3? You do log of 3, x minus 4. Now please pause the video all the time whenever you think you can solve the rest, because it's always a good idea to be able to try and challenge yourself into answering the questions, because that's good practice for the IB exams. So, you have this. Remember, 1, you can change this into a logarithmic expression by saying log base of 3 of 3. Okay? Because 3 goes into 3 once. That's why. So, plus log base of 9 of x. Log base 9 of x. Okay, so now, what do we notice here? Everything's perfect apart from one minor elephant in the room. We have a 9 here instead of a 3. So let's change that. So you get log base 3 x minus 4. Okay? Equals log base of 3, 3. Okay? And now we need to change this. How are we going to change this? How are we going to approach changing this? Well, we need it to be with a base of 3. So, change the base. So log base of 3 of x over log base of 3 of, think, of 9. Beautiful. Now, writing it out again just to make this clear. So, what do we notice here? We have How many times does 3 go into 9? Pause the video and try and answer that. Okay, 3 goes into 9 twice, because 3 squared is equal to 9. So this is actually, this whole expression is the equivalent to 2. Okay? This whole thing is equal to 2. So what you do is you get log base 3 of 3 plus, remember, there's always an invisible 1 in front of the log expression. So this is actually 1, and you always divide the coefficient, not the log expression. So what you have here is 1 over 2, because you have the invisible 1 over 2, 1/2 of the log expression, which is log, so you get 3 of x. Okay, and that's another tip. Always go back and look over your work to see if you've done a stupid mistake, because if you come to the end and your answer is incorrect, then you have to go all the way back up and stress and be confused. So it's just nicer to always be checking. So now you have this, right? Now, the rule of log states that you need to combine in order to be able to cancel out the logs. So let's combine this. You get log, the 1, this can go up, right? So this goes as an exponent. And this, it multiplies. So you get 3x, okay? And this goes to this half is only to the x squared. Remember that, because it's not going to the 3 as well. That's a very important thing to know, because otherwise you're going to get the entire question wrong, which we don't want. So now you have this step, which is beautiful. Now you take out the logs. You get x minus 4 is equal to 3x to the half. Okay, now, as mentioned earlier, how do you get rid of a half? You square both sides. So adios half, and then this whole expression is also squared. Now, so x, remember, just expand this. Okay, now you get this, which is a beautiful expression. Subtract the 9x. So, what is a negative 8 minus 9, you may ask? The answer is negative 17. You get x squared minus 17. X plus 16 is equal to 0. Always want to get it 0, because that is how you get a polynomial, and then you can find the x values. So now you're at a stage where it's all looking pretty good, because the question asks you to solve the equation. So what it's asking you is find the x values. So you get x, because we're factoring this, is equal to 0. Okay? We want to get factors of 16. First of all, 16 times 1, 8 times 2, could be anything, right? But we are trying to solve for negative 17. So what we would do here is we would say negative 16 and negative 1, right? Because these factors are beautiful. This factor is beautiful. But to get the negative 17, you make this a negative, you make this a negative. So finally then, your answers are going to be x is equal to 16, x is equal to 1. And double check, because it's a log expression, you have to plug these back in. So all the way back into the initial, as mentioned earlier. So you have 16. 16 minus 4 is fine. So number 16, fine. Okay, 1. 1 minus 4, no. 1 minus 4 makes the inside of the log negative. We don't want that. So you reject this decision. Adios, you have to draw a line through it to show that you've rejected that option. And so the one that you're going with then is x is equal to 16. That is your final answer.
Number 4. When we're looking at this question, we'll notice a few things initially. We'll do it in writing. There's log base 2 here and here. That's our first immediate sign that something is up, right? That's our first immediate sign. So now that we've recognized it, let's do something about it. When we have two terms on one side of the equation that have the same log base, you can combine them. You can essentially state now that log base 2, x plus 3, times the quantity of x minus 3 is equal to 4. Okay? Cool. Well, the next thing we have to notice is that 2 and 4 are both multiples of each other. Not to mention, this is a constant term. You can express a constant term with logarithms. For example, we can say that this term right here is equal to log base 2 to the power 4. Now, why did you choose log base 2, you might ask? Where did I get this? I got this from here. My goal is to cancel this with this. That's my eventual goal, right? So now, and we only can do that if we have the same log base. So let's rewrite the expression to show you guys how I can do that. Is equal to that. You'll notice now that we have logs of the same base, so we can cancel them. So now we can say that x plus 3 times x minus 3 is equal to 2 to the 4th, which is equal to 16, for anyone that doesn't know that. X squared minus 9 is equal to 16. X squared is equal to 25. Square root 25 is equal to plus or minus 5. Okay? Plus or minus 5. Now, let's just quickly test some solutions just to make sure that they work. Let's just plug in negative 5 here. Negative 5 plus 3 gives you negative 2. I don't know about you guys, but we can't have log base 2 of negative 2. That doesn't work. Here, you plug in negative 5. Log base 2 of negative 5 minus 3, that's negative 8. That still doesn't work either. So, we know the negative doesn't work. X is equal to 5. You can probably express this in a more formal way for the IB exam, but as far as I'm concerned, this works.
Thanks so much for watching this video. Please leave a like and subscribe down below. This would really help us in expanding this channel and doing more videos like this for the future.
If you have any questions, leave them in the comments down below and we'll get back to you as soon as we can.